Okay. So today we are going to start with talking what network is at the end of the day. So network you can say is like a group of devices which are connected. So basically the concept of interconnection between devices. So for example D1, D2, the interconnectability between these two devices is called network, right? So one device can be a host, one device can be a connecting device. So host is like the main device. Let's say this is device 1 and device 2. There will be minor devices like D1 whose task is just to take the information from D1, big D1, and give it to big D2. So these, for example, router, these are called connecting devices. The host is the main device like this. Okay. So now when we talk about network, we must have some criteria from that network, what we can expect from that network, right? So the first thing that we expect from the network is performance. Okay, performance. What do we mean by performance? So basically you can have transit time, you can have let's talk about this. What is transit time? So transit time is basically the amount of time that is required for a message from travel from device 1 to device 2. So basically the total time that is taken to for the device to travel for the message to travel across devices, right? So that is transit time. Next is response time. What do you mean by response time? Basically, let's say you send a request, give me the details for 5 bananas, what is the price, and what is the time then taken for the message to come, right? So that is response time. Response time is kind of the time between an inquiry and a response. Okay. And these are literally one of the few examples. We'll go into detail about everything when we go completely in detail. This is an overview kind of situation. And performance can also depend on, let's say, how many users your app will have, your hardware, what hardware you're using, how optimized the software is, and so many more things, right? So also there can be higher traffic during the time. Traffic means many people are using your server, or many people are sending requests at this moment, and that can, and let's say a server can't handle that, so high traffic can also be. So there is a lot of things on which performance is affected. So one good criteria, one main network criteria is performance. The second criteria is reliability. So what do you mean by reliability? Reliability is how to put this in words. So basically, let's say how many times there is a failure, or let's say from a failure how can you recover as soon as possible. So basically, not only do you need to give an accurate delivery, you also need to give a whenever there's an error, when there is a bug, you have to get that up as soon as possible. And even let's say if there's an attack on your network, right, how do you prevent that? That's also comes under reliability. The third thing is security. Security is when you are sending the data from D1 to D2, how do you secure this data? So there is cryptography, you can hash, encode the data into some kind of an hash or something. So this is also a very important part. And how can you encode, how can you secure the data you're going to send? So these are the main 3 points that you have to keep in mind when you're talking about the criterias of a good network, or the criterias of a network: your performance, your reliability, and your security. That's the main things. Now let's talk about what are the types of connections. Types of connections. So first type of connection is your point to point. Point to point. Okay. So point to point connection is basically, it's a very dedicated connection between two devices. Let's say there is this one device, another device. This is a direct connection between device 1 and device 2, right? So the whole link, the wire between them, whatever the connection between them, is just reserved for those two devices. That is called point to point device. Okay. Second, Second is multi-point. Multi-point means, let's say there will be many devices. Let's say there's a main device D1, it's sharing with D2, D3, D4. So you're seeing that the data is being shared with a lot of people, right? So this might not be the best diagram. Let me draw a new diagram. This is not the best diagram, I would say. The best diagram would be something like, let's say D1 has a common link and it is giving the same data to D2, D3, not the data, like the same link to D4. So you'll see the link is same in this case, and it's basically that same link is sharing. So basically these happens when there's a mainframe server. This is called a mainframe server, and these are small hosts that are connecting to the mainframe server. So this is the main difference you have between point to point connection and a multi-point connection. Okay, and now we are going to talk about a very important thing. We don't go into very much detail in university level or like a college level, but this is a very important thing if you're going to be working in networking or anything. This is literally a branch or a department you're going to be working upon. This is called topology. Topology is how do you physically set up the network, right? So I am drawing these diagrams, right? So let's say multi-point. This is the multi-point system you had, right? So let's say this was 4 devices. What if I had set like D1 to D2, D1 like this, D3, D4. So let's say this is one topology, this is another topology. So which one is better in which kind of connection? So that is the decision you need to make. So this is called topology. Topology is kind of like in the network, how are you physically laying out the network? Okay, so of course you would need more than 2 links, because let's say 2 or more links, because if you have one link it's just the point to point connection, right? But if you have more links, then you can have this topology. Okay, so let's talk about the different kinds of topology. The first topology is called mesh network. Okay, so what is the meaning of mesh network? Every device is connected to another device. So let's say this is one device. So basically all devices are connected to each other. Let me draw this one. Yeah, I think I did draw everything, I think so. Yeah, this is not drawn and this is not drawn. Yeah, so every device is connected to every other device. So how many devices are, so you would see every device is connected to another device, right? So total how many devices is connected for every, let's say n devices are, every n devices is connected to n minus 1 devices, right? But the connection is duplex, right? So one connection goes this side, another connection comes this side. So you're counting the same wire 2 times, so it is 2. So this is the number of links we have in this kind of mesh connection. Okay, so let's briefly talk about what do you think might be the advantages and what might be the disadvantages for this. So advantages is basically there is no congestion. No congestion is not there. Why? Because see, so if everybody is linked to everybody, what is the hop as in like what is the how far do you have to send the signal? You don't have to go through somebody else, right? You just have to send it to one person, that is the closest person. So let's say if this has to send to this, it can just send using this wire, right? So this is the advantage, there is no congestion. Second, it's reliable, because nobody else can understand your data, person can take another data, and it has better privacy as well. Same reason, because if there is a link problem between A and B, you know it's between A and B. None of the other things are there. So it's reliable, and again data is not shared between other people, just A and B, so it's better private as well. So again last point is fault detection is better. That is the thing I just said right now, right? How you can easily debug. So basically if there's a error here, you know the other things are not affected, so it's just this wire and I need to fix it. Disadvantages, it's basically you need lots of cables, so you would need to connect everything with everything, right? So lots of cables. The second thing that's a problem is it's expensive, since you need a lot of cables. These cables are worth in lakhs and crores. Okay. And these are the main two disadvantages. So whenever let's say in a university exam you have to give an answer, advantage is advantage, please try to write exactly these. Okay, so we are done with mesh. Let's talk about this. Okay, let's talk about the second thing, star topology. So what do you think, how does star look? This is very obvious, right? So star topology has a very central figure called a hub. So this is the central figure and it has devices connected like this. So the links are something like this. These are the links here. Okay, so now, so every device is connected to a central hub, and basically whenever the device has to connect to, let's say if somebody has to contact with this to this, so it will send it to the hub, then the hub will send it to that device. So something like, you have to always go through the hub. So now what is the advantage and disadvantage? Let's again go through the same thing, because the main thing here is this. So what is the advantage? The first advantage is it's going to be cheaper, because in mesh you have to have these connection, right? But this connection is not here, so we are saving money. So it's cheaper than mesh. Now it will be, since it's cheaper, it's easier to install because less wires. Then third thing is that, let's say if this device gets down, right? So in this thing, let's say if this device gets down, right? So this link would go down, 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 right? But in this, if it goes down, does not matter, because we have a central hub, right? So it says failure. So let's write it as something like failure of one device doesn't fail the system. I think that would be the best. I don't know how to write this more better, but yeah. 4. And again, fault detection would be better here as well, because if one device goes down, the others are not affected, right? So you know the problem with what device the problem is, and you can go and fix that. Okay. Disadvantage, hub. What if the hub goes down? What if the hub goes down? It's all over, because that is the main part, right? If the hub goes down, your other device, no device is connected. So hub goes down, that's a bad thing. Second thing, for you would see this is the second most expensive thing. Okay, it's cheaper than the mesh, but it's the second most expensive. The other ones are even more cheaper. This is not that good of a disadvantage, but the main thing is the hub. The hub fails, you are done for. Let's now talk about the third one, bus topology. So how does bus topology work? So bus topology is basically, you have a central cable going from one end to another end, and devices will connect to this central cable. So this is kind of the bus topology. So there is this one very big, let's call this a backbone cable. There is this one central backbone cable, and everybody connects with, these are called drop lines. Okay, and so advantages, again, one central wire and these drop lines, so this will be less cable. So less cable means easier installation, right? But disadvantages are more here. What are the disadvantages? So if you want to add a connection, it's harder, because earlier what you had to do, you had to connect with the hub, just one port to port you are connecting, right? Here you have to reconfigure this wire. These are not like ports or something you can connect to, these are wires you're connecting, so it's basically difficult to add new. Okay. Second, over distance, let's say this is the data that's going, right? So there might be some noise and everything, right? So if the data here is full 100%, the signal might be 20% here, right? So the signal is weaker. and there is the difficult fault, because let's say the fault happens here, right, and there are 20 devices behind this, and let's say 100 devices here, right. You don't know where the fault happened, because this 100 devices will fail after that, right. So you don't know, it can be any of those 100 devices, right. So difficult fault detection is a thing. Fourth, if the backbone cable is done, again like the hub, if the backbone cable is down, the whole system is down. So again dependent on only one thing, right. Now let's talk about the final thing, ring topology. So how does ring topology look? Let me draw this. I think that, so let's say something like this, and you have small boxes like these are called repeaters, and then you're connecting the devices like this. Okay, so the devices are connected like this. So let's explain through the diagram. I think that would be better, right. So every device has two, basically it's connected to its two immediate neighbors. So I have drawn it like this. So basically the connection is something like this. So for example, let's say there is 4 here, right. So this gets connected to these two, this gets connected to these two, this gets connected to these two. So this becomes a ring, right. So if you see, the diagram is something analogous to this only. So this is how ring topology is made. So every device is connected to its two immediate neighbors. So now data will only travel in one direction. So here it's not unidirectional. The data will travel, let's say, in this direction. So all around the ring it will go. Okay. So every device is also a repeater. So repeater means what? Repeater means if the signal comes at 100%, it gets diminished, let's say 90%, the repeater will bring back the signal to 100%. So what would be my advantages in this? Again, easy to install, because you just have to connect two wires to the next devices. So one thing that people might think is that there is a wire here, so I'm cutting the wire and putting a device. No, that is not how it's installed. Okay, so let's say if these are the 3 devices, right, and they're already connected in a ring like this. So how do you connect this? You just remove, you don't cut the wire, you just take this wire off. You take this wire off and just connect that wire to this and add one more wire. You just needed one more wire and 2 reconnections, right? So it's easier to install. We are not cutting any wire here. Second is, as I said, it's easy to install and you need only 2 connections to add. And disadvantages is, if one of them breaks, the whole connection is done for, because it's not bidirectional, so the signal will not go. So single break, you are done for. And this is the main thing about ring topology. So I have done it in the most expensive to least expensive kind of way. So ring topology is the cheapest. So with this we are finishing our second lecture, which is mostly about the introduction to networks. Chalo, bye bye.